Welcome to Knowledge Hub. Topic: How do black holes affect time? Black holes, with their mind-bending gravitational forces, do more than just pull in matter. They also have profound effects on time itself. These effects stem from Einstein's theory of general relativity, which tells us that gravity can bend space-time, the very fabric that makes up our universe. But how exactly do black holes warp time? Let's delve into this cosmic phenomenon. The basics of space-time and gravity. To understand how black holes affect time, we first need to grasp the concept of space-time. Space and time are not separate entities but are intertwined into a four-dimensional fabric known as space-time. Massive objects like planets, stars, and black holes create indentations or warps in this fabric, much like a heavy ball placed on a stretched rubber sheet. The greater the mass, the deeper the warp, and the stronger the gravitational pull. Einstein's general theory of relativity predicts that time is not constant, and that it is affected by the presence of mass and gravity. In simple terms, the stronger the gravitational field, the slower time moves relative to areas with weaker gravitational fields. This is known as time dilation. Time dilation near a black hole. Black holes are objects of extreme mass, with gravitational fields so strong that even light cannot escape once it crosses the event horizon, the boundary around a black hole. As you approach a black hole, the gravitational pull becomes increasingly intense, and this has a dramatic effect on time. If you were to observe someone falling towards a black hole, you would notice that as they get closer to the event horizon, their clock would appear to tick more slowly than yours. The closer they get, the slower their clock would tick, until it seems to almost stop entirely as they reach the event horizon. From your perspective, it would take an infinite amount of time for them to actually cross the event horizon, while for them, time would continue to move normally. This phenomenon occurs because, near a black hole, space-time is so warped that time essentially stretches out. This is why black holes are sometimes said to be time machines, though not in the conventional sense. Rather than traveling through time in the way science fiction often portrays, black holes slow down time relative to the outside universe. Gravitational time dilation is not just a theoretical concept. It has been confirmed through experiments and observations. One of the most famous experiments involves atomic clocks, which are highly precise timekeeping devices. When one atomic clock is placed on the ground and another is flown on a jet, the clock on the jet, which is in a weaker gravitational field, due to being farther from Earth's center, ticks slightly faster than the clock on the ground. This effect is also considered in GPS satellites orbiting Earth. These satellites are farther from Earth's center and therefore experience a weaker gravitational pull. Their clocks tick faster compared to clocks on Earth. Engineers must account for this difference, known as gravitational time dilation, to ensure GPS systems work accurately. Now consider this effect in the context of a black hole, where gravity is millions or billions of times stronger than on Earth. The time dilation near a black hole is so extreme that it has led to fascinating thought experiments and real-world scientific inquiries. The event horizon is the boundary around a black hole where escape velocity exceeds the speed of light. Once something crosses this boundary, it cannot return. From the perspective of an outside observer, an object approaching the event horizon appears to slow down as it gets closer. The object would never seem to actually cross the event horizon but would instead appear to freeze in time. However, from the perspective of the object itself, time would seem to continue normally as it crosses the event horizon. This paradoxical situation highlights the strange and counterintuitive nature of space-time near black holes. The extreme time dilation near black holes also has implications for the future. If a person were able to survive near a black hole and then return to Earth, they might find that much more time had passed on Earth than they experienced. This concept is a staple of science fiction, where characters experience time travel by orbiting or approaching a black hole. In the far future, as technology advances, understanding and potentially harnessing the effects of time dilation near black holes could open new possibilities for space exploration. However, the intense gravitational forces and radiation near black holes would make this a formidable challenge. Black holes are not just objects of immense gravitational pull, they are cosmic time warps that stretch and bend time in ways that defy our everyday understanding. Through the lens of general relativity, we see that time near a black hole moves slower relative to the rest of the universe. This phenomenon, while difficult to comprehend fully, has been supported by both theory and observation. As we continue to study black holes and their effects on spacetime, we gain deeper insights into the nature of the universe itself. These enigmatic objects challenge our understanding of physics and push the boundaries of what we know about time, space, and the cosmos. Stay tuned to Knowledge Hub as we explore more fascinating topics in the universe.